Okay, we are going to go over square root basics. It's important for us to understand the numbers 1 through 20 squared and having those in our minds in order to be able to estimate square root values of non-perfect squares. So 1 through 20 are perfect squares when we multiply them. So it's important for us to know those numbers. So we want to know 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, and 20. So hopefully these first 10 are definitely ones that you know. 1, 4, 9, 16, 25, 36, 49, 64, 81, and 100. These other ones, it's good to know the numbers 11 through 20 because they help you when you are estimating larger squares that are not perfect squares. So 11 is 121, 12 is 144, 13 is 169, 14 is 196. They have the same numbers, but they're in slight reverse. 15 is 225, 16 is 256, 17 is 289, 18 is 324, 19 is 361, and 20 is 400. Sorry. So it's important for you to know these squares because they help you when you are estimating future or non-perfect squares and trying to find the closest one decimal number. So we're going to get into that and figuring out how to estimate non-perfect squares. So I'm going to erase this really fast so that we can go over how we do that. Okay, so the steps when we are estimating non-perfect squares. Step number 1 is we are going to sandwich the non-square between two perfect squares. So if, but these are all going to be done in a square root. So if we're continuing with that sandwich metaphor, the square root, we're going to now find the square root of the bread slices, which are our perfect squares that we sandwich the other square root between. So it will look like a whole number is less than the square root of our non-perfect square is greater than the other whole number. So a whole number is less than our square root, which is less than the other perfect square whole number. Then we are going to make an educated guess. And test it. Finally, we are going to check and compare our guesses with one another to see which number is the closest. And hopefully you don't have to do step number 5, but you repeat steps 3 and 4. Okay, so let's get into some examples of how this works and what it would look like. Okay, so if we want to, if we want to find the square root of 8, 8 is not a perfect square. So we need to figure out what are the two perfect squares that 8 is between. So the two perfect squares I can think of are the square root of 4, which is less than the square root of 8, which is less than the square root of 9. Okay, so that was step number 1. Step number 2 is we want to find the square roots of our bread slices. So we know that the square root of 4 is 2, which is less than the square root of 8, which is less than 3. So we know that the square root of 8 is going to be somewhere between the numbers of 2 and 3. So if we're looking on a number line, 1, 2, and 3, we know it's right here. And we know that 8 is much closer to 9. So I think we're going to start with a number, oh, sorry, this is a 3. A number that is significantly closer to 3, because we know that 8 is a much closer number to 9 than it is to 4. So we are going to start out with my guess of 2.9. So then we test it. We do 2.9 times 2.9. 9 times 9 is 81. Carry the 8. Then we get a 26. We bring down the 0. 18. 2 times 2 is 4. Woo! Sorry about that. That's 5. So we get 1, 14, carry the 1. Okay, so we get 8.41. And that's kind of close to 8, but I think maybe we can get closer. So I would try the next number down because 8.41 is pretty close. So let's try 2.8. 8 times 8 is 64, 16, 22, carry the 0, 2 times 8 is 16, 2 times 2 is 4, 5, 4, 8, 7. So now we kind of have the numbers 8.41 and 7.84. So we need to determine which of these two numbers is closer to 8 so that we can find, and 7.84 is only 0.16 off, while 8.4 is 0.4 away. So we know that 2.8 is closer than 2.9. So the square root of 8 is approximately, and you do these fun little curvy ones, 2.8. So that would be our answer. We will go over a couple more examples of this in class. Hopefully this helped you understand how to estimate square roots. Again, we want to sandwich it between two perfect squares that go inside of the square root. And then we're finding the square root of those bread slices on the outside to give us a whole number, which is less than the square root we're trying to find, which is less than another whole number. You make an educated guess between those two whole numbers of what you think will be the closest. And then you check and compare by multiplying it out. And if need be, you can make a new educated guess and repeat the steps.